Have you ever seen something like this? Hundreds, even thousands of lights dancing in the sky, moving like a single entity. It looks like magic, but it's very real technology, the drone swarm. But how on earth does a group of robots fly in perfect formation with no one, and I mean no one, in charge? Well, in this explainer, we're going to pull back the curtain on the unseen mind that makes it all possible.
I mean, really think about it for a second. When you see these incredible light shows or these coordinated flights, your brain automatically asks, who's flying all of them? The mind-bending answer? Nobody. Not a single person is at the controls. So, how? How is that even possible? Well, the secret isn't in some futuristic control room. It's actually in a concept as old as nature itself.
It's a field called swarm intelligence. And the two big ideas you got to remember here are decentralized and self-organizing. This just means that instead of one central brain telling every single drone exactly what to do, the group itself acts like one big, intelligent organism. Each individual drone is just following a few simple rules, and from all those little local interactions, this complex, coordinated behavior just emerges.
Now, to figure out how to do this, engineers didn't look to faster computers or bigger command centers. Nope. They looked somewhere much, much older. They looked to the natural world.
That's right. The solution was right there in front of us the whole time. In the way ants forage for food, or how a flock of starlings creates those absolutely breathtaking patterns in the sky. In these systems, there's no king ant with a tiny crown or a leader bird shouting orders from the front. It's a completely different and frankly more brilliant way of achieving complex, coordinated action.
So let's break this down. On the left, you've got the old-school centralized way. Think of a king commanding an army. It works, sure, but if you take out the king, the whole army just descends into chaos. It has a massive single point of failure. But on the right, you have the decentralized model, like that flock of birds. Each bird is only paying attention to its immediate neighbors, but somehow the entire flock turns as one. There is no single point of failure. It's robust, it's resilient.
And this approach, inspired by nature, gives the swarm some serious superpowers. Because it's decentralized, it's incredibly tough to take down. Because it's self-organizing, it's smart and can figure things out on its own. It becomes amazingly adaptable to new situations and scalable. You can have 10 drones or 10,000. And all of that leads to this incredible emergent collective behavior that no single drone could ever achieve on its own.
Okay, so the concept is cool, right? But the big question is, how do you actually translate the behavior of an ant into computer code? Well, that's where we get to the digital toolkit. You do it with some seriously clever programming called, get this, bio-inspired algorithms. These are basically sets of rules and mathematical models that copy the simple, yet super effective, strategies that nature has been perfecting for millions of years to solve complex problems.
Now, don't let these names scare you off. Just think of them as different digital tools for different jobs. Ant colony optimization, for instance, helps the swarm find the best, most efficient route, kind of like how real ants leave a chemical trail to the best food source. Then you've got particle swarm optimization, which helps them adjust their flight paths on the fly. And flocking algorithms are exactly what they sound like. They're the simple rules like don't get too close and match your neighbor's speed that keep them from crashing into each other.
And this is where it gets really, really cool. When you combine that decentralized structure with these smart, nature-inspired algorithms, you don't just get a cool light show. You get a system that is incredibly resilient. You get a system that is literally built to survive.
This quote from the research just nails it. That lack of a central leader isn't a weakness. It's the swarm's greatest strength. It's the key feature that allows the whole system to self-organize, to adapt, and ultimately to survive and be reliable, even when things go very wrong.
And the data backs this up in a huge way. I mean, look at this number. In some pretty advanced simulations, these systems have achieved a 93% success rate. But a success rate at what?
That's a 93% mission success rate, even when the swarm is under direct electronic attack. We're talking about situations where an enemy is actively trying to trick its GPS and jam all its communications. For any normal centralized system, that's game over. Mission failed. For the swarm, it's just another obstacle to work around.
And this is how it does it. Let's say one drone gets taken out. Does the whole thing panic and fall out of the sky? Nope. Step 1. The other drones detect one of their own is gone. Step 2. The network instantly adapts, finding new ways to talk to each other. Step 3. The drones just fluidly reorganize their formation to fill the gap. And Step 4. The mission simply continues. It literally heals itself in real time. It's incredible. So look, this isn't just some theory stuck in a lab or a cool computer simulation. Let's talk about how this technology is already being used out in our world, right now.
One of the most powerful and, frankly, life-saving applications is in disaster response. When every single second counts, a swarm of drones can do things a single drone or even a team of humans just can't.
I mean, just imagine an earthquake hits a huge area. You could deploy a swarm that spreads out instantly, searching cooperatively. They can even use AI to recognize human postures to perform triaging in real time, figuring out who needs help most urgently. And all the while, they're building live, up-to-the-minute maps for the first responders on the ground.
But it's not just about emergencies. Swarm technology is set to completely revolutionize how we maintain our world and even how we grow our food.
Think about it. Instead of dangerous human jobs, you can have swarms performing coordinated inspections of things like power lines. They can fly into tricky terrain to pollinate crops with surgical precision. They can even be used for hyper-targeted pest control, which drastically minimizes the environmental impact. The possibilities are huge.
And of course, with any technology this powerful, there's always another side of the coin, and that, inevitably, is its use in defense and security. The ability to launch coordinated surveillance missions or even complex ambushes is fundamentally changing military strategy. A swarm can overwhelm traditional defenses and disrupt enemy systems in ways that were basically science fiction just a few years ago. It's presenting entirely new kinds of challenges for global security.
Which brings us to our final, and maybe the most important question of all. We started this journey by building a system inspired by nature so we could make a better tool. But as this technology evolves, as these swarms learn and adapt more and more on their own, where do we draw the line between a tool and a teammate? That's a question we're all going to have to start thinking about, probably a lot sooner than we think.